So this section is on quadratic equations and their properties. Okay, so the first thing I want you to do is write the properties in your notes. So I want you to pause the video and write the properties and what each of those properties mean or how we find them. Okay, so one thing I would like for you to remember is that a parabola is what we call quadratic graph. So the graph of a quadratic is a parabola. It is a U-shaped graph that's either positive by going up or negative by going down. Now, we have a project that's due in a couple weeks, and we had some parabolas or quadratic equations that went down because they were Angry Birds and they were being shot in the air and they came back down. So that would be a negative parabola because it's going upside down, going towards negative infinity. Most of the parabolas we look at are going to be just normal U-shaped graphs, and they're positive parabolas. Okay? So let's go over each of these points, or each of these things. The vertex. The vertex is where this graph turns. So there'll be a point where it stops going in one direction, turns and goes in the other. That would be the vertex. The maximum or minimum value is determined by whether the graph is a low point, or the vertex is a low point, or a high point on the graph. And that would be determined by the y. How low did the graph go or how high did the graph go? Then we have the axis of symmetry. The axis of symmetry is an invisible line that goes right through the middle of the parabola, so that if it was folded over that line, it will be symmetrical. Okay? It is the x value of the vertex. Now, we've been talking about x-intercepts because we had that on our last test. To solve for a quadratic, you find the x-intercepts. Okay? So the x-intercepts have a lot of different names. They are called the zeros of a function. They are called the roots, or they're called solutions. And all that means is where does the graph cross the x-axis. Okay? Domain for parabolas is going to be all real numbers. Each one of them, the x keeps going. It's not going to change. All real numbers. However, the y, or the range, will be determined by the maximum or minimum values. Okay? Now, let's get started. We're going to graph something. And we're going to use Desmos to graph it. Okay? So the first one we're going to graph is this negative 3x squared plus 6x minus 2. Okay? So I'm going to pull up Desmos. And now that my graph didn't show up where I needed it to, I'm going to put the graph over here so you can see it. So I'm just going to put the equation in: negative 3x to the square plus 6x minus 2. Okay, so that's our graph. And notice this graph is upside down. Okay, so let's just look at a couple of things that happen. When we graph something in Desmos, you see these gray dots? We get gray dots at critical points. One of them is the y-intercept, so that's where it's crossing y. Another 2 or 1 would be where it crosses x, so both of these are where it crosses x. And then guess what that is? That is the turning point, and the turning point is your vertex. Okay, so I'm going to go back to the slide, but this is our graph, and first thing I want to write is what is our vertex. So our vertex is 1, 1. Okay, Now we need to determine, is this graph a maximum or a minimum? Is the vertex the highest point on the graph or the lowest point? And it's a maximum. And what is that maximum value? What is the highest point on the y that it goes? It's going to the 1. So that's the maximum value. Excuse me. All right, the next thing is the axis of symmetry. Now remember I told you the axis of symmetry was this invisible line that goes straight through the middle of this parabola. Right where the vertex is, it goes right through that vertex. And its value is whatever the x is at the vertex, and the x is a 1. But this is a line, so we have to write it as an equation. X equals 1. Okay? Now, let's look at another thing. Another thing was roots, or your solutions, or your x-intercepts. So let's see what that looks like. Now our x-intercepts are here and here. And that would be 0.4 and 1.6. 0.4 and 1.6. Okay? Now let's talk about domain. Remember, domain I told you would be all real numbers. All real numbers. But your range is determined by the maximum or minimum. So let's look at our graph. If the maximum value on the y that we get to is a 1, then all my other values for y must be less than that. So if I'm going to describe my range, it's y is less than or equal to 1. Okay? All right, I want to try another one. I want us to try this last one over here. Let's see if I can get this to slide a little bit. I want us to try this one right here. So go to Desmos and put that in. X squared plus 2x minus 3. So x squared minus 2x minus 3. Is that what I said? Or was it plus 2x? Plus 2x minus 3. Okay. So this is what your graph should look like. Okay. Let's double check it. Make sure your equation is correct. X squared plus 2x minus 3. Remember I told you key points are with have a dot on them. So these 2 points are key, and this one is key. Now I did not ask you for the y-intercept, but if you get a question like that, that's the y-intercept where it crosses y. Alright, so the first thing we want to start with is the vertex, and the vertex is a -1, -4. So vertex -4, -1, I think is what we said. -1, -4, I said it backwards. -1, -4. Okay? Now we have to determine, is this a maximum or minimum? This is the low point on your graph. So it is a minimum, and the lowest point it gets to is a -4. So our minimum value is -4. And notice it's the y value of the vertex. Our axis of symmetry. Remember we said it was the x value of the vertex. In this case, it's x equals -1 for our axis of symmetry. Now, our roots. Remember, our roots are where we cross x. We cross x at -3 and +1. So -3, +1. Our domain, we said it was all real numbers, right? Don't even have to look at the x's. All real numbers. but our range we do have to look at. All right, so let's look at our graph again. The range starts here. We start with this -4 on the y-axis, okay? And all my other y's are above that, are bigger than -4. So I would say my range was y is greater than or equal to a -4. Okay? Now, what if our graph does not cross the x-axis? Will we have roots? Let's just try something. Let's see what we get here. You see my graph this time doesn't cross the x-axis, so there are no roots. I do have a vertex, which means I have a minimum value of 2, and I have an axis of symmetry of -1. But I do not have any x-intercepts, so there are no zeros, no roots. My domain is still all real numbers. My range is y is greater than this 2, because my graph goes above it. And this is a minimum value of 2. It is the lowest point on my graph. Okay? So, what you're going to do today is you're going to get an equation. And I'm going to ask you to name all of these things. So we're going to try this one. Y is -3x squared. And that's all we're going to put in there. -3x squared. Alright, your graph should look like this. And notice I've only got 1 point marked. Man, that 1 point must be real important. It is my turning point. So, it is my vertex. It's a 0, 0. This graph is upside down. So this is the highest point it gets to. So it's my maximum, and the value is 0. It is also my axis of symmetry. If I drew a line through the vertex, it would be at x is 0. Roots. Where does it cross x or touch x? It crosses x at 0. That is the only 0 I have. My domain is all real numbers. It's not going to change. My range. My graph starts at 0 and all my values for y are below that. So y is less than or equal to 0. Okay? So I want to try another one. -x squared plus 5. Let's see how much we can do. -x squared plus 5. This is our graph. See how much we can get it through. Our vertex is at 0, 5. The maximum, because that's the highest point, the maximum value is 5. Our axis of symmetry, that line that goes through the vertex, is x equals 0. It is the 0 of the vertex. My roots are at -2.2 and +2.2. My domain is all real numbers, and my range starts at 5 and then all the numbers below 5. So my range would be y is less than or equal to 5. All right, I hope you understand all the properties of a quadratic.